Hello all, good morning. PowerPoint presentation on MongoDB. Let us see about MongoDB in detail in this slide. So we are going to see what is MongoDB. What is MongoDB used for? MongoDB features, advantages of MongoDB, disadvantages of MongoDB, MongoDB's technologies, MongoDB's new technologies, the difference between MongoDB and SQL, and the difference between MongoDB and RDBMS, and what MongoDB is great for and what it is not great for, the history of MongoDB, the purpose behind MongoDB, MongoDB CRUD operations and websites using MongoDB in the slides. So moving on to the next slide, let us see what is MongoDB. So what is MongoDB? MongoDB is an open source NoSQL database management program. NoSQL is used as an alternative to traditional relational databases. NoSQL databases are quite useful for working with large sets of distributed data. MongoDB is a tool that can manage document-oriented information, store or retrieve information. MongoDB is used for high-volume data storage, helping organizations store large amounts of data while still performing rapidly. Organizations also use MongoDB for its ad hoc queries, indexing, load balancing, aggregation, server-side JavaScript execution, and other features. MongoDB is a document database with the scalability and flexibility that you want with the querying and indexing that you need. MongoDB's document model is simple for developers to learn and use, while still providing all the capabilities needed to meet the most complex requirements at any scale. MongoDB stores data in flexible, JSON-like documents, meaning fields can vary from document to document and data structure can be changed over time. The document model maps to the object in your application code, making data easy to work with. Ad hoc queries, indexing, and real-time aggregation provide powerful ways to access and analyze your data. MongoDB is a distributed database at its core, so high availability, horizontal scaling, and geographical distributions are built in and easy to use. MongoDB is free to use. Versions released prior to October 16, 2018 are published under the AGPL. Moving on to the next slide, why we use MongoDB. It was invented in the 70s to store data. It stores documents or objects, and nowadays everyone works with objects such as Python, Ruby, Java, etc. And we need database to persist our objects. And embed documents and arrays reduce needs for joins. MongoDB is built on a large-scale out architecture that has become popular with developers of all kinds for developing scalable applications with evolving data schemas. As a document database, MongoDB makes it easy for developers to store structured or unstructured data. It uses a JSON-like format to store documents. This format directly maps to native objects in most modern programming languages, making it a natural choice for developers as they don't need to think about normalizing data. MongoDB can also handle high volume and can scale both vertically or horizontally to accommodate large data loads. MongoDB was built for people building internet and business applications who need to evolve quickly and scale elegantly. Companies and development teams of all sizes use MongoDB for a wide variety of reasons. Using MongoDB enables your team to go further and faster when developing software applications that handle data of all sorts So let us see what is MongoDB used for. Some of the wide areas where MongoDB is used as a database are its quick and iterative mobile and web app development and analytics based on the data stored in the database, Internet of Things, and high consistency and near zero downtime requirement systems like payments and banks. And when it comes to document model, the document data model is a powerful way to store and retrieve data in any modern programming language, allowing developers to move quickly. And in case of deployment options, MongoDB is available in any major public cloud such as AWS, Azure, and Google Cloud through MongoDB Atlas, in large data centers through the Enterprise Advanced Edition, or free through the Open Source Community Edition. And it's very easy to get started quickly. MongoDB has a great user experience for developers who can install MongoDB and start writing code immediately, and it's fully scalable. MongoDB's horizontal scale-out architecture can support huge volumes of both data and traffic. And defined community. MongoDB has developed a large and mature platform ecosystem. It has a worldwide community of developers and consultants, making it easy to get help. It also has an enterprise-grade support offering. So moving on to the next slide, let us see about MongoDB features. MongoDB is a document-oriented NoSQL database platform which provides numerous important features. Among them are the document model with a flexible schema to best store data for your application needs, replication for better data availability and stability, sharding for horizontal scalability, ad hoc queries for optimized real-time analytics, and it supports ad hoc queries. In MongoDB, you can search by field range query, and it also supports regular expression searches. Indexing. You can index any field in a document. Replication. MongoDB supports master-slave replication. Duplication of data. MongoDB can run over multiple servers. The data is duplicated to keep the system up and also keep its running condition in case of hardware failure. Load balancing. It has an automatic load balancing configuration because of data placed in shreds. And it uses JavaScript instead of procedures. It is a Himalayas database written in C++. It provides high performance. It stores file of any size easily without complicating your stack. And last but not the least, it is easy to administer in case of failures. And it has flexible schema, fast queries. It writes large data set without failure. It joins data across collections, and it has powerful indexing and search. It has full storage directly in MongoDB database, and it has best analytics and availability. So let us see about some important features of MongoDB. The first one is flexibility. MongoDB uses documents that can contain subdocuments in complex hierarchies, making it expressive and flexible. MongoDB can map objects from any programming language, ensuring easy implementation and maintenance. Next, flexible query model. The user can selectively index some parts of each document or a query based on regular expressions, ranges, or attribute values, and have as many properties per object as needed by the application layer. Next, native aggregation. Native aggregation allows user to extract and transform data from the database. The data can either be loaded into a new format or exported to other data sources. The next one is schemaless model. Applications get the power of responsibility to interpret different properties found in a collections documents. And some salient features MongoDB features or general purpose database. MongoDB can serve diverse sets of data and multiple purpose with a single application. Next, flexible schema design. The document-oriented approach allows non-defined attributes to be modified on the fly. This is a key contrast between MongoDB and other relational databases. Then, load balancing and scalability. It is built to scale both vertically and horizontally. Using the technique of sharding, an architect can achieve both write and read scalability. Data balancing occurs automatically and transparently to the user by the shared balancer. Next, aggregation framework. MongoDB offers an extract, transform, load framework which eliminates the need for complex data pipelines. The next one is native replication. Data gets replicated across a replica set without a complicated setup. Then security features. Authentication, authorization are taken into account. JSON. JSON is widely used across front-end and API communication. It only makes sense for the database to use the same protocol. Then, MapReduce. MongoDB offers a great tool, MapReduce, to build data pipelines, get in demand scales. So moving on to the next slide, let us see about advantages of MongoDB in detail. So moving on to the next slide, MongoDB advantages. MongoDB brings a host of benefits to the table. Its advantages include flexible and scalable, and no SQL document model, and it has high performance, it has rich query language and automatic sharding, and it has flexible data modeling, and it has abundant community and ecosystem. NoSQL databases are cheaper and easier to maintain. These databases have features like easier data distribution, simpler data models, and automatic repair. These benefits require less representative cost and consequently less expensive. It's open source and incurs favor server cost, and it is free. NoSQL databases use cheaper servers, so the price of data storage and processing is significantly lower. It is easily and highly scalable, and NoSQL databases like MongoDB expand horizontally. You can scale by adding more machines to your resource pool. It supports integrated caching. System memory caching boosts data output performance, and MongoDB has no schema hassles. You can place data into a NoSQL databases without requiring a predefined schema. So you can change the data model and formats without disrupting applications. It is user friendly, and MongoDB offers plenty of useful features like ad hoc queries, aggregation, cat collection, file storage, indexing, load balancing, replication, server-side JavaScript execution, and finally it makes a user-friendly data. So the final advantages are MongoDB has distributed data platform. It is fast and iterative. That means the development is fast and iterative, and it has flexible data model, and it has reduced total cost of ownership, and it has integrated feature set. So these are the overall advantages of MongoDB. So moving on to the next slide, let us see about the disadvantages of MongoDB in detail. So moving on to the next slide, disadvantages of MongoDB. It has the usage of memory server, and it will need a lot of random access memory, and it is less flexible. It's querying, that means it has no joins, and it has no support for transactions, and it has more concurrency issues. Then I've got joins. MongoDB does not support joins like a relational databases, making it challenging to join your stored documents. You can manually code it, but it's time consuming and could affect performance. And it has high reliance on good indexes. If your indexing has any discrepancies or errors, it can negatively impact the speed and performance of MongoDB. Therefore, you will need to spend time fixing and analyzing the indexes you use and duplicate data. MongoDB can suffer from duplicate data, making it difficult to manage your data efficiently. High memory usage. MongoDB demands high memory usage, which requires extra attention to keep under control. This is due to the memory inefficiency of duplicate data, the limited ability to implement joins, and limited data size in nesting. MongoDB limits document size to no more than 16 MB and does not allow nesting beyond 100. So as I said, its joins are not supported. It has high memory usage and limited data size and limited nesting. These are the overall disadvantages of MongoDB. So let us see about the advantages and disadvantages together. The advantages, it has flexible databases, sharding, high availability, scalability, ad hoc query support, easy environmental setup, high speed and full technical support. And when it comes to limitations. It has high memory consumption, limited nesting, joins are not supported, and overall it limits data size. So, in conclusion, MongoDB has its pros and cons like any other software product. Understanding these can help you make the right decisions for your needs. Additionally, using automation to streamline your data handling, such as Sync automation, can provide further benefit regardless of your choice of database system. So these are the overview of advantages and disadvantages. So moving on to the next slide, let us see about MongoDB's technologies. MongoDB 6.0. MongoDB 6.0 adds and improves a number of features such as faster reading of time series data, queryable encryption that enables search for encrypted data, and a preview for a column store index for data analytics application. The next one is MongoDB Stitch, backend as a service platform that offers a RESTful API in an effort to ease application development, as well as let users connect to cloud services and set real-time triggers in databases. And MongoDB Atlas Global Clusters, newer feature that lets users of MongoDB's cloud database service deploy globally distributed systems to boost performance and comply with data governance rules. Then, last but not the least, MongoDB Mobile, beta technology that extends MongoDB applications to mobile devices and equipment on the Internet of Things, and with automatic synchronization of data to backend databases. So let us see about MongoDB's new technology. MongoDB 4.0, database update that supports ACID transactions across multiple JSON documents, and it also includes the beta release of a data visualization tool called MongoDB Charts. Then MongoDB Stitch, backend as a service platform that offers a RESTful API in an effort to ease application development. Then it lets users connect to cloud services and set real-time triggers in databases. Then MongoDB Atlas Global Clusters, a new feature that lets users of MongoDB's cloud database service. It deploys globally distributed systems to boost performance and comply with data governance rules. Then MongoDB Mobile, beta technology that extends MongoDB applications to mobile devices and equipment on the Internet of Things, with automatic synchronization of data to backend databases. So these are all about MongoDB's new technology. Moving on to the next slide, so let us see about MongoDB vs SQL database in detail in next slide. So let us see about the difference between SQL and MongoDB. So in SQL, the database type is relational databases, whereas in MongoDB it's non-relational databases or distributed databases. And in MongoDB, the structure, we have key value pairs, document based, graph databases, and wide column stores, whereas in SQL we use table based databases. Then let us see about scalability. In MongoDB, it's designed for scaling out horizontally by using shards to distribute load across multiple commodity, that means inexpensive hardware. And whereas in SQL, it's designed for scaling up vertically by upgrading on expensive custom built hardware. Then let us see about the strengths of MongoDB and SQL. So in MongoDB, the pairs well with fast-paced agile development teams, and data consistency and integrity is not top priority, and it's expecting high transactions load. Whereas in SQL, it's great for highly structured data and don't anticipate changes to the database structure, and it's working with complex queries and reports. So let us see some other differences. The data schema in SQL is fixed, whereas in MongoDB it's flexible. And the primary database model in SQL is relational DBMS, whereas in MongoDB we use document store. and the licensing is commercial in SQL, whereas it's open source in MongoDB. And we use programming languages like C++ in SQL, and we use C++, Go, Python, JavaScript in MongoDB. And the server operation systems is Windows in SQL, whereas we use Solaris, Linux, and OS X Windows in MongoDB. So these are the overview of SQL vs MongoDB. So let us see both the difference between RDBMS vs MongoDB in detail in next slide. So let us see about the difference between RDBMS and MongoDB. So RDBMS is a relational database, whereas MongoDB is non-relational and document-oriented database. And RDBMS is not suitable for hierarchical data storage, whereas MongoDB is suitable for hierarchical data storage. And RDBMS it's vertically scalable. Example, it has increasing random access memory, whereas MongoDB is horizontal scalable. That is, we can add more servers. And RDBMS has predefined schema, whereas MongoDB has dynamic schema. And RDBMS is quite vulnerable to SQL injection, whereas MongoDB is not affected by SQL injection. RDBMS centers around asset properties like atomicity, consistency, isolation, and durability, whereas SQL centers around the CAP theorem, that is consistency, availability, and partition tolerance. RDBMS is row based. MongoDB is document based. RDBMS is lower in comparison with MongoDB. MongoDB is almost 100 times faster than RDBMS. RDBMS supports complex joins, whereas MongoDB doesn't support for complex joins. RDBMS is column based, whereas MongoDB is field based. RDBMS does not provide JavaScript client for querying, whereas MongoDB provides JavaScript client for querying. RDBMS supports SQL query language only, whereas MongoDB supports JSON query. So these are the other differences between RDBMS and MongoDB. That is, RDBMS uses table and MongoDB uses collection. In RDBMS it uses row, whereas in MongoDB we use JSON document. And RDBMS and MongoDB is similar with index, and we use join in RDBMS, and we use embedding and linking in MongoDB, and we use partition in RDBMS and shard in MongoDB. So these are the overview of the difference between RDBMS and MongoDB. So moving on to the next slide. MongoDB is not great for. So it is highly transactional applications and problems requiring SQL. And these are some companies which use MongoDB in production. Moving on to the next slide. What is MongoDB is great for? So MongoDB it is a replacement for web applications, and it is semi-structured content management, and it has real-time analytics and high-speed logging, and it's caching and high scalability, and Web 2.0, media, SaaS, gaming, healthcare, finance, telecom, and government. These are the sectors where MongoDB is based. So let us see about the history of MongoDB. MongoDB is equal to humongous DB. So it is an open source document based, and it's high performance, high availability, and automatic scaling. CP on CAP. Then MongoDB is a source available cross-platform document-oriented database program. It is classified as a NoSQL database program, and MongoDB uses JSON-like documents with optional schemas. And MongoDB is developed by MongoDB Inc., and current versions are licensed under the server-side public license, which is considered non-free by some organizations. and distributions. And MongoDB is a member of the Marsh. So moving on to the next slide, the history of MongoDB. The US software company Tension began developing MongoDB in 2007 as a component of a planned platform as a service product. In 2009, the company shifted to an open source development model, with the company offering commercial support and other services. In 2013, Tension changed its name to MongoDB in .5. On October 20, 2017, MongoDB became a publicly traded company listed on Nasdaq as MDB with an IPO price of $24 billion per share. On November 8, 2018, with a stable release 4.0.4, the software's license changed from AGPL 3.0 to SSPL. On October 30, 2019, MongoDB teamed up with Alibaba Cloud, who will offer its customer a MongoDB as a service solution. So customers can use the managed offering from Baba's global. So what is the general purpose to build MongoDB? MongoDB describes themselves as a general purpose database, but IMO, the sweet spot for the database, is in the development of modern applications with rapidly changing requirements utilizing modern programming stacks. MongoDB has the following strong advantages when building a modern application. The flexible schema allows you to iterate through product design faster than databases like Oracle, since changes to the data model don't require database configuration or rebuilt applications built with MongoDB that can easily integrate with continuous integration platforms, since all the data model is encapsulated with the program code. Then MongoDB reduces the friction between object model and database model, because there's no need to always convert between the representation of data in the application and that in the database. So that having been said, carefully constructing the data model is still essential for optimal performance. The use of JavaScript as a database language is very convenient when programming in JavaScript elsewhere in the application, particularly if you are using Node.js. So MongoDB is open source and so can be used without license cost. Though MongoDB, the company, offers enterprise and hosted options that have significant advantages over the open source version. And MongoDB is relatively easy to set up and scaling is relatively straightforward. And administration of MongoDB in production is less expensive than for many other databases. And MongoDB is not such a good choice when the database is going to be used for analytics or data warehousing. And in that scenario, you might be looking for Hadoop or a relational database system. So these are the overall. Moving on to the next slide, let us see about the CRUD operations in MongoDB. CRUD operations describe the conventions of a user interface that let users view, search, and modify parts of the database. So MongoDB documents are modified by connecting to a server, querying the proper documents, and then changing the settings properties before sending the data back to the database to be updated. CRUD is data oriented and it's standardized according to the HTTP action verbs. So when it comes to the individual CRUD operations, the create operation is used to insert new documents in MongoDB database, and the read operation is used to query a document in the database. The update operation is used to modify existing documents in the database. The delete operation is used to remove documents in the database. And okay, now let us see how to perform CRUD operations. Now that we define MongoDB CRUD operations, so we can take a look at how to carry out the individual operations and manipulate documents in MongoDB database. So let's go into the process of creating, reading, updating, and deleting documents and looking at each operation in turn. So the first one is create operation. For MongoDB CRUD, if the specified collection doesn't exist, the create operation will create the collection when it's executed. The create operations in MongoDB target a single collection and not multiple collections, and Insert operations in MongoDB are atomic on a single document level. So MongoDB provides two different create operations that you can use to insert documents into a collection. So db.collection.insert1 and db.collection.insert many. So insert1. As the namesake, insert1 allows you to insert one document into the collection. For this example, we are going to work with a collection called records.db. We can insert a single entry into our collection by calling the insert1 methods on records.db, and then we can provide the information we want to insert in the form of key value pairs, establishing the schema. So db.records.db.insert1, name Marsh, age 6 years, species dog, owner address 380 WFIR AVE, shipped true. If the create operation is successful, a new document is created. The function will return an object where acknowledged is true and insert id is the newly created object id. In db.records.db.insert1, name Marsh, age 6 years, species dog, owner address 380 W.FIR ABE, shipped true, acknowledged true, insert id object id, and insert many. It's possible to insert multiple items at one time by calling the insert many decide collection. In this case, we pass multiple items into the chosen collection and separate them by commas. Within the parentheses, we use brackets to indicate that we are passing a list of multiple entries. This is commonly referred to as a nested method. db.records.db.insert many, name Marsh, age 6 years, species dog, owner address the 380 W.FIR AVE, shipped true, and name Kitana, age 4 years, species cat, owner address 521 E.Cortland, shipped true. So let us see about read operations and read update. And so let us see about update and read operations. So update operations, like create operations, update operations operate on a single collection and they are atomic at a single document level. An update operation takes filters and criteria to select the documents you want to update, and you should be careful when updating documents as updates are permanent and can't be rolled back. This applies to delete operations as well. For MongoDB Create, there are three different methods of updating documents: db.collection.update1, db.collection.update many, db.collection.replace1, and update one. We can update a currently existing record and change a single document with an update operation. To do this, we use the update one method on a chosen collection, which here is records.db. To update a document, we provide the method with two arguments, an update filter and an update action. And the update filter defines which items we want to update, and the update action defines how to update those items. We first pass in the update filter, then we use the set key and provide the fields with which we want to update as a value. This method will update the first record that matches the provided filter. db.records.db.update1, name Marsh, set owner address 451 W. Street A204, acknowledgement is true and matched count is one modified account, and id and object id, you can mention any id. And okay, this is update many, and update many allows you to update multiple items by passing in a list of items, just as we did when inserting multiple items. This update operations uses the same syntax for updating a single document. That is, for example, you can give the species name as dog and set age as 5 and acknowledged as true and matched count 3 and modified count 3, and you can give any other object id, and you should repeat the same process several times, and by giving the same set of data. And the replace one method is used to replace a single document in the specified collection. The replace one replaces the entire document, meaning fields in the old document not contained in the new will be lost. And here db.records db.replace one name Kevin name Maki acknowledged true matched count and modified count is 1, and you should repeat the same process with several IDs. So these are about update and so moving on to the next slide. Let us see about delete operations. Delete operations operate on a single collections like update and create and operations. Delete operations can also automate for a single document. You can provide delete operations with filters and criteria in order to specify which documents you would like to delete from a collection. The filter options rely on the same syntax that read operations utilize. In MongoDB has two different methods of deleting records from a collection, that is db.collection.delete1, db.collection.delete many, and delete one. And delete one is used to remove a document from a specified collection on the MongoDB server. A filter criteria is used to specify the item to delete. It deletes the first record that matches the provided filter. And db.records.db.delete1 name Aki acknowledged true delete count 1 db records db find id and object id, you can mention any id, and it is repeated the same time several fields. And delete many is a method used to delete multiple documents from a desired collections with a single delete operations, and it is just passed on to the method and the individual items are defined with filter criteria as in delete one. And db.db records delete many species stock acknowledged is true deleted count 2 db records to db find id with object id, you can mention any id, so it's repeated the same way. And these are all about the CRUD operations, and it's the overview for CRUD operations update create. So these are the list of companies using MongoDB. MongoDB has cultivated a reputation as a versatile and flexible database and is currently used today as a backend data store of many high-profile businesses and organizations such as Forbes, Facebook, Google, IBM, Twitter, and many more. And so this is the final slide of MongoDB. Last but not the least, so this is the final slide of MongoDB, and it's the overview of companies and sites using MongoDB. Thank you everyone. Hope you got idea of MongoDB and overview of MongoDB, like features, advantages, disadvantages, CRUD operations, history, etc. Thank you everyone once again.